Okay, part 5 of our journey. Wait, what? How did I get these notifications? Well, 2 hours ago. What did I do? The heck? I didn't do anything. Okay, maybe it's a mathematic thing, I don't know. Okay, so yeah. So we finished yesterday the multiplication division. So yeah, we achieved that much points. So it's gonna go to the negative numbers. Intro to negative numbers. Okay, let's go.
In this video, I want to
Wait, am I recording? Yep, I am. And
familiarize
audio.
ourselves with
Okay.
negative numbers. In this video, I want to familiarize ourselves with negative numbers and also learn a bit of how do we add and subtract them. And when you first encounter them, they look like this deep and mysterious thing. When we first count things, we're counting positive numbers. What does a negative number even mean? But when we think about it, you probably have encountered negative numbers in your everyday life. And let me just give you a few examples. So before actually I give the
Whoa.
example, the general idea is a negative number is any number less than 0. Less than 0. And if that sounds strange and abstract to you, let's just think about it in a couple of different contexts. If we're measuring the temperature, and it could be in Celsius or Fahrenheit, let's just say we're measuring it in Celsius. And so let me draw a little scale that we can measure the temperature on. And so let's say that this is 0 degrees Celsius. That is 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius. Now, let's say that it's a pretty chilly day, and it's currently 3 degrees Celsius. And someone who predicts the future tells you that it is going to get 4 degrees colder the next day. So how cold will it be? How can you represent that coldness? Well, if it only got 1 degree colder, we would be at 2 degrees. But we know we have to go 4 degrees colder. If we got 2 degrees colder, we would be at 1 degree. If we got
No, it's
3
going to
degrees
explode.
colder, we would be at 0. But 3 isn't enough. We have to get 4 degrees colder. So we actually have to go one more below 0. We have to go one more below 0. And that 1 below 0, we call that -1. We call that -1. And so you can kind of see that the
Grade
number
run me,
line,
that's
as
illegal.
you go to the right of 0 on the number line, it increases in positive values. As you go to the left of the number line, you're going to have -1. Then you're going to have -2. You're going to have -3. And you're going to have,
-3,
depending on how you think about it,
-4.
you're going to
Okay,
have
cool.
larger negative numbers. But I want to make it
Larger
very
negative
clear.
numbers.
-3 is less than -1. -3, there is less
Yes.
heat in the air than -1. It is colder. There's less temperature there. So let me just make it very clear. -100 is much smaller than
Negative 1.
1. Or sorry, much smaller than -1. You might look at 100 and you might look at 1, and your gut reaction is say, wow, 100 is a much larger number than 1. But when you think about it, -100 means there's a lack of something. -100, if it's -100 degrees, there's a lack of heat. So there's much less heat here than if we had -1. Let me give you another example. Let's say in my bank account today, I have $10. Let me do this in a new color. So let's say today I have $10. $10.
Wow, ten
Now let's
dollars. Pretty
say
sick.
I go out there because I feel good about my $10, and let's say I go
Yeah.
and spend. Let's say I go out there and I spend $30. And for the sake of argument, let's say I have a very flexible bank, one that lets me spend more money than I have, and these actually exist. So I spend $30. So what's my bank account going to look like? So let me
Oh
draw a
no,
number
that's
line
gonna look
here.
illegal.
And you might already have an intuitive response. I will owe the bank some money. So let me write this over here. So tomorrow, what is my bank account? So you might immediately say, look, if I have $10 and I spend $30, there's $20 that had to come from someplace. And that $20 is coming from the bank. So I'm going to owe the bank $20. And so in my bank account, to show how much I have, I could say 10 minus 30 is actually negative $20. So in my bank account tomorrow, I am
10
going to
minus
have
30. You know,
negative $20.
$20.
So if I say I have negative $20, that means that I owe the bank. I don't even have it. Not only do I have nothing, I owe something. It's going in reverse. Here I have something to spend. No one owes, if to some degree, if my $10 is in my bank account, means the bank owes me $10. I have $10 that I can use to go spend. Now all of a sudden, I owe the bank. I've gone the other direction. And if we use the number line here, it should hopefully make a little bit of sense. So that is 0. I'm starting off with $10. I'm starting off with $10. And spending $30 means I'm moving 30 spaces to the left. So if I move 10 spaces to the left, if I only spend $10, I'll be back at 0. If I spend another $10, I'll be at negative 10. If I spend another $10 after that, I will be at negative 20. So each of these distances, I spent $10, I'd be at 0. Another $10, I'd be at negative 10. Another $10, I would be at negative 20. And this whole distance right here is how much I spent. I spent $30. So the general idea, when you spend or if you subtract, or if we're getting colder, you would move to the left of the number line. The numbers would get smaller. And we now know they can get smaller than 0. They can go to negative 1, negative 2. They can even go to negative 1.5, negative 1.6. You're getting more and more negative the more you lose. If you're adding, if I go and get my paycheck, I will move to the right of the number line. To the right of the number line. Now with that out of the way, let's just do a couple of more pure math problems and just think about what it means if we were to say, let's say 3 minus 4. So once again, this is exactly the situation that we did here with the temperature. We're starting at 3 and we're subtracting 4. So we're going to move 4 to the left. We go 1, 2, 3, 4. So that gets us to negative 1. And when you're starting to do this, so you really understand what a negative number means, I really encourage you to visualize the number line and really move along it depending on whether you're adding and subtracting. Now let's do a couple of more. Let's say I have 2 minus 8. 2 minus 8. And we'll think about more ways to do this in future videos. But once again, you just want to do the number line. You have a 0 here. We're at, let me draw the spacing a little bit. So we have 0 here. We're at 1, 2. If we're subtracting 8, that means we're going to move 8 to the left.
Yeah.
So we're going to go 1 to the left, 2 to the left. So we've gone 2 to the left to get to 0. We have to move how many more to the left? Well, we've already moved 2 to the left. To get to 8, we have to move 6 more to the left. So we're going to have to move 1, 2, 3, 4, 5, 6 more to the left. Well, where is that going to put us? Well, we were at 0. This is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So 2 minus 8 is negative 6. Cool. You have to move 2 minus 2 would be 0. When you're subtracting 8, you're subtracting another 6. So we go to negative 6. We go 6 below 0. Let me do one more example, and this will be a little less conventional for you, but hopefully it will make sense. Let us take, and I'll do this in a new color. Let me take negative 4 minus 2. So we're starting at a negative number, and then we're subtracting from that. And if this seems confusing, just remember the number line. Just remember the number line.
Negative 4 minus 2.
So this is 0 right here. This is negative 1, negative 2, negative 3, negative 4. So that's where we're starting. Now we're going to subtract 2 from negative 4. So we're going to move 2 to the left. So we're going to go, if we subtract 1, we will be at negative 5. If we subtract another 1, we are going to be at negative 6.
Cool.
We are going to be at negative 6. So this is negative 6. Let's do another interesting thing. Let's
Wait,
start,
you said that was the last one.
start at negative 3. Let's say we have negative 3. Instead of subtracting something from that, let's add 2 to it. So where would this put us on the number line? So we're starting at negative 3. And we're adding 2. So we're going to move to the right. So you add 1, you become negative 2. But if you add another 1, which we have to do, you become negative 1. You move 2 to the right. So negative 3 plus negative 2 is negative 1. And you can see for yourself that this all fits our traditional notion of adding and subtracting. If we start at negative 1, and we subtract 2, we should get -3. It kind of reverses this thing up here. -3 plus 2 gets us there. Then if we start there and we subtract 2, we should get back to -3. And we see that happens. If you start at -1, if you start at -1, right over here, and you subtract 2, you move 2 to the left, you get back to -3. So hopefully this starts to give you a sense of what it means
It
to
does.
deal with or add and subtract negative numbers. But we're going to give a lot more examples in the next video. And we're actually going to see what it means to subtract a negative number.
Intro to negative numbers. Here's a number line that should look wrong. It starts 0 then counts up by 1 from there. You know, if we were to get 1. Yep. What happens if we go into the 0 though? We get negative numbers. Let's practice. Move the dot to -4. Am I supposed to do it like that? Okay. 6.5. Wow, okay. First time I've dealt with decimals and shit. Why do we need negative numbers? Negative numbers have values less than 0. So below 8 is 8 degrees below 0 degrees. It is less than 0. We can say that temperature is -8. A few more negative situations. A bank is positive numbers represent others, negative numbers represent withdrawals. How would a bank represent a withdrawal of 19.43? Losing points -15, -15. Okay, next video. Wait, next video? I'm on the practice section. In a board game, negative numbers can represent moving backwards, and positive number of cards represent moving forward. For example, Nuha drew a card with 4 and moved forward. Rahad draws a card 0, not moving any spaces at all. Kalpana is rescuing a hiker. On Kalpana's ship is rock. A positive number represents the elevation of hikers above her, of hikers below her. From Kalpana's currency, the hiker she is rescuing is negative 371 meters. The hiker is 371 meters below Kalpana. Whoa, below sea level. Canasta is a card game where negative. Okay, the same shit from the article. How would gaining 12 points be represented? Last month, Seth made money by selling stocks. His investment income was $401. This month, Seth's investment income is negative 261. What does this mean? Wait, what? I don't know this. I don't know about stocks, but I guess Seth lost. Credit card companies use negative balances to represent when the credit card owes the customer money. Oh, okay. The person when the customer owes their credit card company. Sneha, what kind of name? That's so weird. First time I read that kind of name. There's a balance of $0 with her credit card company. Oh, no one owes no one. Eric is swimming along the surface of the sea. He uses positive numbers to represent elevations above the sea. Oh, the surface of the sea, negative 3%. Okay. Wait. Mark is sitting on the deck of the ship above Eric, and Ariel is diving beneath Eric. Who could be at elevation -3? Wait, what? Eric is at the surface of the sea, so I guess that's 0. He uses positive numbers to represent elevations above. Oh, okay. Who could be? It's gonna be Eric. What? Oh shit! It's Ariel. Oh my gosh! I needed upgrading. A theme park uses positive numbers to represent when a roller coaster is above ground, and negative numbers to represent. shy. It's made one mistake. Let's try again. John lost money by selling cows. Gain. You use negative. Oh, it's the finish line. The freezing point of water is 0 degrees Celsius. Scientists use positive numbers to show temperatures above the freezing point. The snowy desert scarp keeps the ice in their snow cones at the temperature. What does the ice in the snow cones is 15 below the freezing point. A bank uses positive numbers to represent deposit. Withdrawal. This morning, Romain noticed that the temperature was below 0 when the temperature was negative 11 and 1/2 degrees. It's afternoon now and the temperature is 938 degrees. What is that? Why are we doing? We're dealing with fractions, mixed numbers, and it hasn't even thought yet. But okay. Temperature is above 0. A chameleon is looking for prey. Let positive numbers represent the elevation of prey above the chameleon and elevation of prey below the chameleon. The chameleon spots of light 4 and the grasshopper at 6. What does its elevation of the chameleon? The elevation of a city is positive if the city is above sea level and negative if below sea level. The elevation of New Orleans is negative 3 and 3 meters. Is below. New Orleans. Okay. Where is the blue point on the number line? It's negative. Wait, it's negative 6. Move the dot to 10 on the number line. That's 10. Where is the blue dot on the number line? The 12, 18. Where is the blue point on the number line? It's gonna be negative 10. Negative 8 on the number line. Where's the blue dot on the number line? It's negative 6. Where's the blue point on the number line? Oh shit, negative 8, 12, 16, negative 16, bro. Okay, cool. Ordering negative numbers.
I've got 5 numbers here, and the goal is to order them from least to greatest. And it might be obvious to you that all 5 of these numbers are negative numbers. So let's just think about which of these is the greatest number. And you might be tempted to say, oh, well, 40s would, if these were all positive, 40 would be the greatest. So you might be tempted to say negative 40 is the greatest. But you have to realize what the negative is telling you. And to think about that, think about if these were your dollar amounts in your bank account. Would you rather have negative $40 in your bank account or negative $7 in your bank account? Negative 40 means that you owe the bank $40. So it's 40 less than having nothing. Negative 7 would mean that you owe the bank only $7. So it's actually the case that negative 40 is less than negative 7. And out of all of these numbers, it is the least of all of them. So negative 40 is the very least
30,
that you could do. That's the least amount of money that you would want out of these comparisons in your bank
7.
account, or the smallest amount of money. You owe the bank $40. Not only do you have nothing, you owe the bank $40. Then the next smallest number would be negative 30. it would be negative 30. And then the next smallest after that would be negative 25. Negative 25. And then the next smallest after that would be negative 10.
Yep.
Negative 10.
Negative
And then
10.
finally, the greatest of all of these numbers, the greatest, and I will do it in pink, the greatest of all of these numbers is negative 7. And if it's still not obvious to you, you could also think of them in temperature terms. Which of these is the coldest temperature, whether you're talking about Celsius or Fahrenheit? Negative 40 would be the coldest temperature. Negative 7 would be the warmest temperature. There would be the most heat in the air at negative 7. Another way to think about it is we could draw a number line. So let's draw a number line right over here. If this is 0, and we could put maybe positive 7 up here. Positive 7 isn't one of these numbers, but then we can plot all the other numbers. So this right here might be negative 7. If that's negative 7, then maybe this right over here would be negative 10. Notice we go further and further to the left of 0. And then we go a little bit further to the left, we get negative 25. A little bit further to the left than that is negative 30. Negative 30. And then you go even further to the left. You go even further to the left, and you get to negative 40. So look at
scale.
If you think of it this way, the least of these numbers is the one that's furthest to the left of on the number line, and the greatest is the one that's furthest to the right.
Okay, so am I supposed to do this thing before? Okay, so learn first. Well, I know that number farthest to number the greater process. For example, 5 is greater than 2. Is 5 farther than right than to the number line. Okay, the farther numbers farther than for both positive and negative numbers. But for example, negative 2 is greater than negative 5 because negative is farther to the right than negative 5 on the number line. Yeah, it's true. True or false? 1 is greater than 4. No. Negative 1 is greater than negative 4. That's true. Negative 5. No. Yeah. Oh, it's pretty sick. Okay, cool. No, not the quiz. Am I supposed to do the quiz now? No. Still have this practice. 0 to 5. Lowest on the left. Okay. Okay, this must be pretty easy. It's gonna do it. 0, 20, 7. Okay. Yeah. That amount. Okay. There we go. Sick. Okay. Let's take the quiz. Okay. 5 problems. Smooth it out to negative 6 on the number line. Negative 4, negative 6. Okay. Divers use positive numbers to represent the height of the diving board and to represent the depth of the dive. How would height of the diving board? I don't know what that is. How would divers represent a dive with a depth up? It's negative. Where's the blue point on the number line? Oh, okay. 12, 18, 22, 20. Oh shit. So it's 30, right? Negative 30. This is 5. 1, 2, 3, 4, 5. Yeah. Cool. Okay. Great. Number opposites.
What I want to do in this video is think about what it means to have an opposite of a number. So let me draw a number line here. So let's draw a number line. And let's put some numbers on this number line. So we can start at 0. And if we go to the right, we have positive numbers. 1, 2, 3, 4, 5. As we go to the left, we get more and more negative. So negative 1, negative 2, negative 3, negative 4, and I could keep going on and on and on. So let's pick one of these numbers. Let's say that we pick the number 3. What is going to be the opposite of the number 3? Well, the opposite of the number is a number that's the same distance from 0, but on the other side. So 3 is 3 to the right of 0. 1, 2, 3. So its opposite is going to be 3 to the left of 0. 1,
Wow, that's
2,
pretty sick.
3. So the opposite of 3 is negative 3. And let me make a little table here. So if we have the number, and then we have its opposite. We have its opposite. So we just figured out that if you have the number 3, its opposite is going to be negative 3. Now what if your number is negative?
It's negative.
What if
And
your
you
number,
have
let's say the
a
number
positive
negative 4? What's the opposite of that? And I encourage you to pause the video and try to think about it on your own. Well, you say, okay, negative 4 is right over here. That's negative 4. It is 4 to the left of
someone's
0.
calling me.
1, 2.
I'm gonna pause a bit. Right, I'm back.
2, 3, 4 to the left of 0. So its opposite is going to be 4 to the right of it. So 1, 2, 3, 4. It's going to be positive. It's going to be positive 4. And so you're probably starting to see a pattern here. The opposite of a number is going to be the opposite sign of that number. If you have a positive 3 here, its opposite is going to be negative 3. If you start with negative 4, its opposite is going to be positive 4. So one way to think about it, it's going to have the same absolute value, but have a different sign. Or another way to think about it is, however, if this is 3 to the right of 0, its opposite is going to be 3 to the left of 0. Or if the number is 4 to the left of 0, its opposite is going to be 4 to the right of 0. So let's do one last one. What is the opposite of, what's going to be the opposite of 1? Well, 1 is 1 to the right of 0, so its opposite is going to be 1 to the left of 0, or negative 1. Or another way to think about it, 1 is positive, so its opposite is we're going to change the sign. Instead of being positive, it's going to be negative. It's going to be negative 1. Either way you could think about it.
The opposite of a number is the number of the other side of 0 on the other side of 0 number line. So the distance from 0. Yeah. Move the dot to the opposite of 2. Okay. Numbers. That's pretty sick. We have decimals. What's the following number line for the question below? Which of the following is the opposite of A? That's E. Why is it negative E? What the hell? Wait, what? It's the opposite of A. And it is the middle, and it's gonna be E, right? What the heck? For real? Let's answer this one. I'm supposed to say negative A. Oh my gosh. So weird, man. Okay. Which of the following is also the opposite of A? Also the opposite of A. Should be E. Should the following equations are true? Okay. A. No. No. Yeah. No, not next video. Yeah, next video.
In another video, we've already talked about what an opposite of a number is, but we'll review it a little bit. If we start with a positive number, say the number 4, if you have a number, and then we want to think about what the opposite of that number is. Opposite. This is just the symbol for number, or shorthand for number. So if the number is 4, what is its opposite? Well, 4 is 1, 2, 3, 4 to the right of 0. Positive 4 is 4 to the right of 0. So its opposite is going to be 1, 2, 3, 4 to the left. So it's going to be negative 4. Or another way to think about it, if you have a positive number, its opposite is going to be the negative of that number. So another way of thinking about it is that this negative literally means opposite. One way to think about it, this is the number that is the opposite of 4. So let me write this down. So if I write negative 4, negative, let me write this, negative 4, that literally means,
Opposite
so
of
you
4.
can take this negative symbol as meaning opposite of 4. Opposite of 4. If you were to say negative, and instead of saying a specific number, let's just say a letter that could represent a number. So if I said negative a, that means the opposite of the number a. That means the opposite. Let me do that blue color, opposite of a. And if this confuses you a little bit, just look, a could be any number right over here. So let me draw a number line just so this can be make a little bit more sense, hopefully. So this is a number line. And let's say, let me put some tick marks here. And I don't know how much each of these tick marks jump, but let's say that a is some number that is right over here. Well, negative a is going to be the opposite of a. So if a is 3 tick marks to the right, negative a is going to be 3 tick marks to the left. 1, 2, 3. And so the opposite of a is going to be this value right over here. And we can write that. We could write opposite of a over here. We could literally write opposite of a is that number right over there. Or as a shorthand, we can just write negative. We can just write this is negative a right over here. Negative a. So with that in mind, if we literally view this negative symbol as meaning the opposite of whatever this is, let's try something interesting. What would be the negative
of negative?
Another color. Let me do this. What would be the negative of
a negative?
Negative 3. I encourage you to pause the video and think about it.
Yeah, it's gonna
Well, we just said this negative means the opposite. So you can think about this as meaning, this means the opposite of negative, the opposite of negative 3. So what's the opposite of negative 3? Well, negative 3
it's recording. Thought I forgot.
is 3 to the left of 0.
We're showing it.
1, 2, 3. So its opposite is going to be 3 to the right of 0. 1, 2, 3. So it's going to be positive 3. So this is equal to.
Wait, can you explain
Positive
again?
3. So it's, well, negative 3 is 3 to the left of 0. 1, 2, 3. So its opposite is going to be 3 to the right of 0. 1, 2, 3. So it's going to be positive 3. So this is equal to positive 3. Or we could just write positive 3 like that. So hopefully this gives you a better appreciation for what opposite means, and also how it relates to the actual negative symbol. Hey, we could keep going. We could do something
negative
like
of
what is the negative of the negative of negative
Negativeception.
let me do a different number of negative 2. Well,
Oh shit!
this part right over here, the negative, the opposite of negative 2, which is really the opposite of 2. Well, that's just going to be 2. Every time you say opposite, you flip over the number line. So this flips you over the number line 2 to the left, and then this flips you back 2 to the right. So all of this is going to be 2. But then you're going to take the opposite of 2, so that's just going to be negative. That's going to be negative 2. If you threw another negative in front of this, it would be the opposite of all of this. It would be the opposite of negative 2, and then all of a sudden it would become positive. So every time you put that negative in front there, you're flipping on the other side of the number line.
Cool. I wish you could have drawn the number line. It's a pretty sick animation. What's the opposite of a number? Yeah. And opposite of number is a negative sign. The opposite of negative 2 can be a negative of negative 2.2. What's this video? Yeah, I've watched this already. What's the opposite of 5 to 4? So 4 positive. Which represents the opposite of 0 on the number line? Wait, what? Opposite of 0? It's gonna be still 0, right? Whoa, 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 whoa. What the heck happened? Yo. Move the dot to negative C. Oh shit. Where? Practice. A 6, so still 6. What can we say about point E? E is equal to negative A. Yeah. Okay. So the practice. What number is the opposite of 8? Negative 8. Which point represents the opposite of negative 3 on the same number line? It's gonna C. Grab the opposite of 1.5 on the number line. A graph, not grab. What number is the opposite of 8 point? Negative 8, 7.3. Which point represents the opposite of 0 on the number line? Still Z. Graph the opposite of negative 4 on the number line. Okay. What number is the opposite of 5? It's gonna 5, 4, 5, 4. Seems 0. Move the dot to negative A on the number, and it's gonna be still 5. Which point represents negative 7? It's A. Whoa, whoa. Oh shit, oh my god. It's E. Negative symbol is opposite. What is this? Okay, so negative A. That's gonna be positive still, right? Shit, I made a mistake. Okay, let's go. Let's try again. Move the dot to negative B on the number line. Which point represents negative? It's gonna be positive 2. Still 0. Move the dot to negative E. 2.5. Negative 2.5. Okay, cool. Proficient. Absolute value examples.
Find the absolute value of x when x is equal to 5, x is equal to negative 10, and x is equal to negative 12. So the absolute value, it's almost, the way of writing it is almost more complicated than what it really is. The absolute value is really just the distance of x from 0. Distance from 0. So let me just draw a fast number line over here. So if I were to first, let's just put 0 right over here since we're thinking about the distance from 0. So let's just think about the absolute value. Let's think about the absolute value of x when x is equal to 5. So that's equivalent to the absolute value of 5. We just substituted 5 for x. The absolute value of 5 is the distance of 5 from 0.
It's going to be still 5.
So you go 1, 2, 3, 4, 5. 5 is exactly 5 to the right of 0. So the absolute value of 5 is just 5. Now, I think you already get to see this is a pretty straightforward concept. Now let's do something a little more interesting. Absolute value of negative 10. When x is, or the absolute value of x when x is equal to negative 10. So let's just put negative 10 in for x. This is the distance that negative 10 is from 0. And so let's just go negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. I should extend the number line more. So this right here is negative 10. So how far is it away from 0? Well, it's 10 to the left of 0. So you put a 10 here. And so in general, absolute value will always be a positive quantity. And when we're thinking about just absolute values of just numbers, it's just going to be really the positive version of that number. Let's do one more. Well, they tell us to do one more. The absolute value of x when x is equal to negative 12. So we have the absolute value of negative 12 is going. We don't even have to look at the number line. It's just going to be the positive version of negative 12. It's just going to be equal to 12. And this is just saying that negative 12 is 12 away from 0. And we could draw it over here. This negative 11, negative 12 is right over here. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 away from 0.
So 4. No. The absolute value symbol is a bar on each side of the number. For example, instead of writing the absolute value of 6, you just write, okay. Was it worded here? Yeah, it was. Yep. So this one we're using the symbol. Okay. A says 0. True. A is no, it's false. Wait, what? Okay, A is definitely less than 0. Opposite is 0. And I messed on this one, I guess. A is less than. Oh yeah. Definitely. Comparing absolute values.
Let's do some examples comparing absolute values. So let's say we were to ask ourselves how negative 9, the absolute value of negative 9, I should say, how that compares to the absolute value of, let me think of a good number. Let's say the absolute value of negative 7. So let's think about this a little bit, and let's think about what negative 9 looks like, or where it is on the number line, where negative 7 is on the number line. Let's look at what the absolute values mean, and then we should probably be able to do this comparison. So there's a couple of ways to think about it. One is you can draw them on the number line. So if this is 0, if this is negative 7, and then this is negative 9 right over here. Now, when you take the absolute value of a number, you're really saying how far is that number from 0, whether it's to the left or to the right of 0. So, for example, negative 9 is 9 to the left of 0. So the absolute value of negative 9 is exactly 9. This evaluates to 9. Negative 7 is exactly 7 to the left of 0. Is exactly 7 to the left of 0. So the absolute value of negative 7 is positive 7. And so if you were to compare 9 and 7, this is a little bit more straightforward. 9 is clearly greater than 7. And if you ever get confused with the greater than or less than symbols, just remember that the symbol is larger on the left-hand side. So that's the greater than side. If I were to write this, and this is actually also a true statement, if you took up these without the absolute value signs, it is also true that negative 9 is less than negative 7. Notice, the smaller side is on the smaller number. And so that's the interesting thing. Negative 9 is less than negative 7, but their absolute values, since negative 9 is further to the left of 0, it is the absolute value of negative 9, which is 9, is greater than the absolute value of negative 7. Another way to think about it is if you take the absolute value of a number, it's really just going to be the positive version of that number. So if you took the absolute value of 9, take the absolute value of 9, that equals 9, or the absolute value of negative 9, that is also equal to 9. When we think of it visually, that's because both of these numbers are exactly 9 away from 0. This is 9 to the right of 0, and this is 9 to the left of 0. Let's do a few more of these. So let's say that we wanted to compare the absolute value of 2 to the absolute value of 3. Well, the absolute value of a positive number is just going to be that same value. 2 is 2 to the right of 0. So this is just going to evaluate to 2. And then the absolute value of 3, that's just going to evaluate to 3. It's actually pretty straightforward. So 2 is clearly the smaller number here. And so we clearly get 2 is less than 3, or the absolute value of 2 is less than 3. So we have a less than right over here. Let's say you wanted to compare, I'm trying to find a suitable color, the absolute value of -8 to the absolute value of 8. Well, one way to think about it is that they are both 8 away from 0. This is 8 to the left of 0. This is 8 to the right of 0. So both of these things evaluate to 8. Absolute value of -8 is 8. Absolute value of 8 is 8. And so clearly 8 is equal to 8. Let me do a couple of more examples. Let's say I wanted to compare the absolute value of -1, and I want to compare that to +2. So the absolute value of -1 is just the positive version of 1, it's just the positive version of -1, which is just 1. So 1 is clearly less than 2, or the other way to think about it, the absolute value of -1 is clearly less than 2. So what we have here is 4 different values, some of them expressed with negative numbers and or absolute value. And what I want to do is I want to sort them from least to greatest, where the least is on the left and the greatest is on the right. So sort from least to greatest. And like always, I encourage you to pause the video and try to work through it on your own. So I'm assuming you've had a try at it. So the easiest way I can think about it is, well, let's just plot them all on a number line. And you might want to draw it out, or eventually you kind of have a number line in your head and you can think about it that way. So let's first think about the absolute value of -27. So what is the absolute value of -27? Well, it's just going to be +27. This right over here is the same thing as +27, because -27 is 27 to the left of 0. 27 to the left of 0. So let's plot the absolute value of -27. Well, it's really 27, so it's going to be right over here. So that is the absolute value of -27. It is +27. All right, then we have -17. Well, -17, let's see, each hash mark here is 3. So this is -9, -12, -15. So -17 is going to be right around there. So that is -17. And then we have -28. So we have -27, and each hash mark is 3, so -28 is going to be right over there. -28. And then finally we have 22.4. So let's see, we have 18, 21, 22 would be here, so 22.4 is going to be roughly right over there. So that is 22.4. So if we want to sort it from least to greatest, well, we just have to start at the left end of the number line. The smallest of them, or the least of them, is -28. Then we go to -17. -17. Then we go to 22.4. Then we go to 22.4. And then we go to the absolute value of -27. And we are done. Let's say that I have 2 numbers on a number line. So let me draw a little quick number line right over here. And the 2 numbers on my number line that I care about, the number A and the number represented by B here. And the way I've drawn it, B is to the right of A on our number line. And by our convention, B is going to be greater than A. So if I wanted to figure out the distance between A and B, what is this distance going from A? I'm going to draw a straight line here. This distance going from A to B. So
absolute value
right over there.
of A
How would I
minus B.
figure it out? Well, I could just take
Or
the
B minus
larger
A.
of these 2 numbers, which is going to be B, and then subtract out the smaller.
Oh
So I
shit.
subtract
B
out
minus
A, and I'll be left with this distance, and this will give me a positive value. When when I want a distance, I should think in terms of a positive value. How far apart are these 2 things? But I was only able to know to do b minus a because I knew that b was greater than a. This is going to give me a positive value. What if I knew that a was greater than b? Well, then I would do the other way around. So let me draw that again. And let me draw another number line right over here. And in this world, I'm going to make a greater than b. So this is b, that is a. And if I wanted to calculate the distance between b and a here, well, now I would take the larger of the two, a. Remember, I want the positive distance here. And then I would subtract out the smaller. I would do a minus b. Well, so here I did b minus a, here I did a minus b, but what if I didn't know which one was greater? If I didn't know whether b or a was greater, what could I do? Well, what you could do is just take either a minus b or b minus a and take the absolute value. And if you do that, it doesn't matter if you take b minus a or a minus b. It turns out that regardless of whether a is greater than b or b is greater than a or they're equivalent, that the absolute value of a minus b is equivalent to the absolute value of b minus a. And this is equivalent, either of these expressions is the distance between these numbers. And I encourage you to play around with the negatives, see if you can factor out some negatives and think about the absolute value, and it'll actually make a lot of sense why this is true. In another video, I might do a little bit more of a rigorous justification for it. But I think the important thing for this video is to see that this is actually true. So let's say we're in a world. Let's get a number line out and let's look at some examples. So let's say that we want to figure out the distance between let's say -2, the distance between -2 and +3. So we can look at the number line and figure out what that distance is. To go from -2 to +3, or the distance between them, we see is 1, 2, 3, 4, 5. Actually, we'll draw a straighter line here. This distance right over here, is equal to 5. You see it right over here. 1, 2, 3, 4, 5. Or you could go. You have to go 5 backwards to go from 3 to -2. But let's see that what I just wrote actually applies right over here. So if we took -2 to be our a and 3 to be our b, then we could write this as the absolute value of -2 minus 3 minus 3. What is this going to be equal to? Well, this is going to be equal to -2 minus 3 is -5. So it's the absolute value of -5. And so this indeed equals 5. So notice I subtracted the larger number from the smaller number. I got a negative value, but then I took the absolute value of it that gave me the actual distance between these two numbers. Now what if I did it the other way around? What if I took 3 minus -2? So it's going to be
No
3,
shit.
the
3 minus
value
-2
of 3. We do it in the blue color.
You haven't
The
dealt with that
absolute
addition
value
subtraction
of 3
with
minus
negative numbers.
3 minus, and in parentheses, I'll write the -2. -2. Now, if you subtract a smaller number from a larger number, you should get a positive value. So the absolute value sign here is just kind of extra. You don't really need it, and let's verify that that's true. This is going to be 3 minus -2. That's the same thing as 3 plus +2, or 5. So this is going to be the absolute value 5, which of course is equal to 5. So hopefully this makes you feel good that if you want the distance between two numbers, you subtract one from the other, and it doesn't matter which order you do it. You can subtract 3 from -2 or -2 from 3. Be careful with the negative symbols here. And then take the absolute value, and then that is going to give you the distance between these two numbers. And this is super important because later in your mathematical careers, you're going to see a math professor just say, oh, I care about the distance between two variables, a and b, so the distance is a minus b, and then later they might write it like this. And then to realize that these are actually the same thing, and they're going to give the same expression, the same value, and they represent the distance between these numbers.
Distance between 2 points formula. I want it squared. Wait, what? Distance from 0 positive absolute value 4. I've been through this. I've been through this. What's 4.6? Yo, that's not right. Absolute value of 4.6? What the heck? Oh, okay. So, the absolute value of this is gonna be 4.6. Oh, okay. I didn't understand the question first. Let's try again. Keep going, or how we answer? Let's try it again. Positive value of 0.6. 0.9. 1.8, negative 1.8, and 1.8. 7.9. Let me see. Okay, cool. Next. It's gonna be equal. Least to greatest. So least to greatest. Oh my god. I can't believe I messed that up. Holy shit. Oh my god. That's the absolute value to find distance. Which of the following expression represents the distance with a negative 3. Okay. No. It should be negative 3 minus negative 0. This one's positive 3, so that's not the answer. Cicero and Themistocles what? Run for the same political office. Cicero received W votes in this election and V votes. Which of the following expression always represents how many votes more winners received than the loser? Select the number line that matches the expression 4 minus 1. Oh, okay. Absolute value of not the above. I mean, like, what the hell is this? June 9 dropped a sandbag from a hot air balloon at a target that is 250 meters below the balloon. At this moment, the sandbag is 75 meters below the balloon. Distance between the sandbag 150. None of the above. Oh shit, it's pretty tricky. Why is this turning to 70 negative? I mean, this thing could be. Oh no, it's not the above. What? Okay. sure about this one. This one. It's this one? What the hell is this? Negative 75 minus negative 250? Why? Okay, so let's understand. That's 250 meters below the balloon. Oh? Ah, yeah, I see now, I see now. So the target is about 150 below. That's oh shit. So the following expression represents a bit the distance between negative 4 and 1. So negative 4 is 1. Okay, above. No, it's actually negative. The shape of the following expression represents the distance between 5.5 and 478 on a number line. Okay, so this. No, it's none of the above. You're piloting an airplane to prepare for landing. You change the plane's altitude from A meters to C meters. Which of the following expression always represents the distance between two altitudes? Okay, I always make one mistake. What is this? Could be this one. Oh, so the other one's negative. No, it's gonna be. And the other one's gonna be positive. It's gonna be B. Let's say to her right, so it's positive. And then minus her Labrador. Turn to her left. So it's gonna be B. Right? Which of the following expression represents the distance between 3.9 and 4. Okay, so negative 3.9. No. Both are negative, so there should be some kind of opposite thing happening. Which of the following expressions represents the distance between 4.35 and negative 2? Negative 2 minus 4.35. Yeah, this one said 4.5 plus. What's there a plus? Suppose your car has H liters of engine oil in the morning. During the day, some oil may have leaked. You may have added more oil or both. The oil level in the evening is G liters. Oh, none of the above. Select the numbers line model matches the expression negative 6 minus negative 3. I mean, oh, none of the above. Oh shit, it's this one. Negative 6 and this one. Yeah. Eva sees a dolphin 3.8 meters below sea level and a bird 4710 meters above sea level. Which of the following represents a vertical distance? Okay. So examine negative 3.2. 47 minus. Yeah, it's pretty much. Let's do the quiz. Fill in the blank. Oh, it's gonna be. Which of the following expression represents the distance between negative 1/4 and negative 3/4? Oh, it's this one. Which point represents the value of negative 1 on the number line? Del. Okay. C. Oh, the opposite of negative 1. It's gonna be D. Okay, so negative A. That's 5 to negative 5. Graph the opposite of negative 3/4. Positive 3/4. Let's see his effects. Intro, there we go. Adding and subtracting negative numbers. Let's go.
Find the sum of negative 15 plus negative 46 plus negative 29. Now to do this, let's just first visualize what each of these numbers look like. So I'm going to draw a number line for each of them. Negative 15 might look something like this. So if this is 0, and let's say that this is negative 15, I could represent negative 15 as, if I'd like to, an arrow that points from 0 to negative 15. The length of the arrow is the absolute value of this. It's the distance from 0. So the length here is 15. And the negative says that we are pointing to the left. So the absolute value is 15. That's the length of that arrow. Let's do the same thing for negative 46. So once again, let me draw my number line. Let me draw a number line. Put 0 is going to be right over there. And negative 46 is going to be someplace over here. Negative 46. Notice, same exact idea. The distance between negative 46 and 0, or another way to think about that is the absolute value of negative 46. This distance right over here is going to be 46. This distance right over here is going to be 46. And its direction is to the left. That's why it is the number. That is why we get to the number negative 46. The negative really tells you whether you're to the left or the right of 0. But the absolute value says how far are you to the left or the right of 0. And then finally, let's do the same thing for negative 29. Same thing for negative 29. So once again, let me draw my number line. Draw the, no, that's, I want to use the yellow again. So draw my number line. Let's say that this is 0. Then negative 29 is going to be roughly over here. I'm estimating it. And once again, negative 29 is exactly 29 away from 0. So this length right over here is 29. And it is to the left. That is why it is negative 29. If it was positive 29, it would be 29 to the right of 0. So we've represented all of these numbers. And you can see what their absolute values are like. And now let's think about what happens if you add them. So one way to think about adding these numbers is if you added these arrows. If you put this arrow on top of this arrow, or to the left of this arrow, if you started where this arrow leaves off, and then you put this green arrow, and then you put the orange arrow. So let's do that.
Oh shit, it's going to be super long.
Let's do that. Let's draw that. It's going to be a longer arrow now. So we're going to start at 0. First we have the negative 15. So we're going to move 15 spaces to the left to get us to negative 15. To get us to negative 15. Then we're going to go 46 spaces to the left to get us to negative 15 plus negative 46. So let me draw that. So then we're going to go, and we're going to figure out what that number is in a second. So then we're going to go 46 to the left. That's about that far. This is really just this arrow. I'm now placing it. I'm starting off where the negative 15 started, or where the negative 15 left off, and then I'm putting that arrow after that. And we don't know yet what number this gets us to. We're going to have to do a little math here, and that's actually the point of this problem. But we know what the length of this arrow is. The length of this arrow is 46. It is 46 to the left. And we know the length of this magenta arrow is 15. And then finally, we have this orange arrow. The orange arrow, which we know has a length of 29, although it's 29 to the left. It looks like that. It has a length of 29. So when all is said and done, where are we? Where do we end up on our number line? Well, the total length that we are to the left is going to be 15 plus 46 plus 29, but it's going to be to the left, so it's going to be negative.
Yeah,
so what we can really view this as, since all of these have the same sign, is we could say, look, this is the same thing as the absolute value of negative 15, which is 15, plus the absolute value of negative 46, which is 46, plus the absolute value of negative 29, which is 29. But then take the negative value of it. So let's just add that. 15 plus 46 plus 46 plus 29 is equal to, let's see, 5 plus 6 is 11. 11 plus 9 is 20. Carry the 2. 2 plus 1 is 3. 3
Oh
plus 4 is
yeah,
7.
got
7
it.
plus 2 is 9.
9.
So you get 90. So this entire length here is 90.
Negative 90.
The entire length, if you add up the arrows, you get a 90. But it is not 90 to the right. So if it was 90 to the right, these would all be positives, and then we would just get a positive 90. But this is 90 to the left. So when you add these guys up, you don't get to positive 90, you get to negative 90. So one way to think about it is these are all the same sign. So this is going to be equal to the negative of the absolute value of negative 15, plus the absolute value of negative 46, plus the absolute value of negative 29. And the reason why we're writing this here is this might look fancy, but this is really just the length. This is really just the length of this purple arrow. This absolute value of negative 46, that's really just the length of the green arrow, 46. And this is just the length of the orange arrow, So this is 15 plus 46 plus 29 gave us 90, but it is to the left, so that is why it is negative 90. Find the sum 15 plus negative 46 plus 29. So let's just think about this first part over here, where we have 15 plus negative 46 plus negative 46. And then we'll worry about the plus 29 later on. So let's just do 15 plus negative, let me do that in a different color, plus negative 46. I'm doing that orange. Plus negative 46. Let me draw a number line here just so we can properly visualize what is going on. So that's my number line. We're starting at 15. So let's draw a 0 over here. And so we are starting at 15. 15 could be right over here. So this is 15. Let me draw a big fat arrow to signify this is 15. 15 has an absolute value of 15. So the length of this arrow would be 15. Now, we're adding negative 46 to that 15. That is the same thing. This is equivalent to 15 minus 46. Minus 46, which means we are going to move 46 spots to the left of 15. Negative sign or minus means we're moving to the left on the number line. So we're going to move 46 to the left. So we're starting at 15. And we are going to move 46. We are going to move 46 to the left. So the length of this arrow right here, the length of this arrow is going to be 46. And we're moving to the left. This is the negative 46 that we're adding to the 15. So we're going to end up at some point over here. That point is clearly 0 because we were 15 to the right. Now we're going to move 46 to the left. So we're definitely going to be to the left of 0. So it's definitely going to be a negative number. And we can even think about the absolute value of that negative number. We can just visualize it. We moved this yellow arrow has a length of 15. This orange arrow has a length of 46.
31, right?
The blue arrow that I'm about to draw, which is the sum of these two, is going to have this length right over here. And just visually, how could we figure out the length of this blue part if we know the length of this orange part and we know the length of this yellow part? Well, it's just going to be the difference. It's just going to be the difference of these two. So the absolute value of the sum is going to be the difference between this length, 46, and 15. So this is 46. Let me just figure that out. 46 minus 15. 6 minus 5 is 1. 4 minus 1 is 3. So the length of this is going to be 31. And it's going to be 31 to the left of 0. So this is going to be negative 31 right over here. So we know that this first part over here is negative 31. And then to that, we are going to add 29. We're going to add 29. Let me do that in another color. So what does that mean? That means that we're going to start at negative 31, and we're going to move 29 to the right. We're adding 29. So we're going to move 29 to the right. So maybe that gets us right about there. Trying to draw an arrow of length 29. Let me draw it. I can draw a cleaner looking arrow than that. I'll do it right over here, actually. So then we're going to move 29 over to the right. That's the 29 part. So now this is a positive 29. And so how do we figure out what this is? So this is gonna land us. So this number, this is 29 right here that we're adding. This is going to
Difference
land
again.
us right over here on the
Actually, we
number
don't
line.
need
So
to
how
do
do we figure
difference
out what
thing.
number that is? Well, once
Yeah.
again, we can just visualize it. And eventually you won't have to draw number lines and stuff, but I think it'll be useful here. The number that we're going to do, we're starting at negative 31. We're adding 29 to it. So it's going to make it less negative, but we're still adding less than 31. So we're not going to get all the way back to 0. So we're still going to have a negative number. So we're still going to have a negative number. But how can we figure out the absolute value of that negative number? Its distance. Well, once again, that little white part right there, that white part plus this 29 is going to equal 31 if you just think of absolute value. If we don't think about the signs, if we just think about the length. Or another way to think about it, 31 minus 29 will give us the length of that white part. And of course, it's going to be negative because the negative number here is larger than the positive number, and we're adding the two. So if we do 31 minus 29, 31 minus 29, you could borrow and all of that, but that's clearly just going to be equal to 2. You could say that's 11, this is a 2. You subtract, this is equal to 2. But since it's negative 31 plus 29, it's going to be a negative 2. We're still going to stay negative. We haven't moved far to the right enough to pass 0. So this right here is going to be negative 2. Or another way to think about the length of this white bar, the absolute value is going to be 2. 2 plus 29 is 31. But we're operating to the left of 0, so it's negative 31. This is negative 2. Anyway, hopefully you found that useful. Well, anyway, and let me make it clear. So our final answer is negative 2.
Start the first number, in this case negative 6 plus negative 7. Okay. Move more place to the left, remove them because adding negative decrease our number. Okay. So I have 13, right? Negative 13. Adding a negative number and a positive number. Start at the number of the first number, in this case negative 8. Then add 3 to the right, and then we'll end up negative 5. Yeah. No shit, it's pretty sick. Okay. Let's do the practice. Oh crap, it's hard. It's gonna be a 4, negative 4. It's gonna be 7. It's gonna be 0. No, it's gonna be 0. Wait, what? No, it's gonna be 8, negative 8, man. It's gonna be 1. Okay, cool. 505 energy points. Okay. Intro to subtracting negative numbers. Let's see.
Let's have some practice adding and subtracting negative numbers. So the first example I want to look at is 2 minus 3. So right now I'm just subtracting a positive number from another positive number, but you might already see that I'm subtracting a larger number from a smaller number, so I'm probably, or I will definitely end up with a negative number. But let's just think about this a little bit, and I'm going to do it with the number line. So there's my number line right over there. Now this is 0, this is 1.
Just a sec. Subtracting negative numbers. Okay.
This is 2. This is negative 1. This is negative 2. We could view this as starting at 2. So this is 2 right over here. And then we're going to subtract 3 from that 2. So we're going to move 3 to the left on the number line. So we're going to move 3 to the left. 1, 2, 3. And that gets us to negative 1. This is equal to negative 1. Now let's mix it up a little bit more. Let's imagine what would happen if we had negative 2. Negative 2 minus 3. So this was positive 2 minus 3. Now let's think about negative 2 minus 3. So once again, let's draw our number line.
Negative 5.
And I'll put 0 over here. So this is 0, this is 1, this is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and I could keep going. But we're starting at negative 2, and then we're subtracting 3 again. So once again, we're going to move 3 to the left of negative 2. So we go 1, 2, 3. We end up at negative 5. So this is negative 5. So notice in both situations, we subtracted 3. We moved 3 to the left on the number line. It's just here we started 2 to the right of 0. Here we started 2 to the left. 2 to the left of 0. This is negative 2. Let's do another example with these same numbers. Let's imagine negative 2 plus 2. Sorry, plus 3. And I encourage you to pause this video and try to think about this on your own. So we draw the number line again. I could draw a straighter number line than that. So draw the number line again. And let's say that this is negative 2, negative 1, 0, 1, and 2 again. We're starting at negative 2. We're starting 2 to the left of 0. So we're starting at negative 2, and we're going to add 3. So we're going to go 3 to the right now. 1, 2, 3. And we end up at positive 1. Now let's think about 2. So positive 2. And we're going to subtract a negative 3. So we're going to subtract negative 3. In other videos, we've already talked about this. In fact, there's a video explaining why this actually makes sense. But when you subtract a negative, this is the same thing as adding the positive. So 2 minus negative 3 is the exact same thing as 2 plus positive 3. These two statements are equivalent. And this is just boils down to, this right over here is just going to be 5. Now let's mix it up a little bit more. Let's imagine negative 2. Let's imagine negative 2 minus negative 3. Minus negative 3. Now this might seem really intimidating. I have all of these negatives in place here. But you just have to remember, subtracting a negative like this is going to get you a positive. So this is the exact same thing as negative 2 plus 3. And negative 2 plus 3, we've already seen it right over here. You start at negative 2. You start 2 to the left of 0. And then we're going to go 3 to the right. We're adding 3. 1, 2, 3.
Okay, let's press.
This is Steve, and this is Steve's uncle.
Awesome
and Steve is in a bit of a bind. Not only does he not have any money, but he also owes Michael, who is not depicted here. Does he not have, and this is Steve's uncle.
Oh, a bind.
And Steve is in a bit of a bind. Not only does he not have any money, but he also owes Michael, who is not depicted here. He owes Michael $3. So he actually has a negative net worth. Steve has a net worth of negative 3. Steve's uncle cares about Steve and feels bad that he doesn't even have a 0 net worth. He has a negative net worth. And so Steve's uncle wants to at least take away some of this pain. He at least wants to get Steve back to a neutral net worth, a 0 net worth. And so he decides to take away Steve's negative net worth. So he wants to take away that negative 3. Well, what happens if you take away that negative 3? Well, that should get you back to 0.
Yeah.
If you take away anything, if you have something and you take it away, it should go back to 0. So similarly, if you owe people things and that owing people things is taken away, it also gets back to 0. And another way to think about it is how Steve's uncle would actually take that liability, take that debt away from Steve. Well, the easiest way he could do it, if Steve is starting at negative 3 net worth, is for his uncle to just give Steve $3. Is to just give him $3 so that he can get back to a net worth of 0. So hopefully that makes it a little bit clearer that this and this are intuitively equivalent.
Yeah, they are. Subtract negative numbers. Subtracting numbers is the same as adding the opposite of the number. Yeah, so let's look at the two examples. So we have negative 5 minus negative 7. It's gonna be equal to negative 5 plus negative 7. Wow, what? Real? Okay. 10 minus negative 3 is gonna be 10 plus 3. In both examples, we change subtraction to addition and change the sign of the second number to the opposite sign. Change subtraction to addition. Change the sign. Yeah. Once we have an addition problem, we can solve. Yeah, it's true. Ah, yeah, it's pretty sick. Yeah. Negative minus negative. Let's subtract negative minus negative 6. Right, as an addition problem. Negative 5 plus 6. Start first an hour in the addition problem in this case. So 5 minus negative 6 negative plus 6. Negative double positive 1. Hopefully, plus try and be able to adding percentage points. Our number is 6. Yeah. Positive 1. Yeah. Negative minus positive. Yeah, this one's gonna be going to the left even further. So we write as an addition problem. You know, 7 minus negative 4 minus 7. It's going to be 4. Negative 4 plus negative 7. I think I don't need to do this and make things complicated, so it's pretty enough. Start the number first number in this case. Move 7 less than negative 11, right? Because adding negative 7 decreases our number by 7. That's pretty weird. Okay, okay. So negative 6. So it's gonna be 8. It's been negative 7, man. Okay, cool. Then let's do the practice exercises. How have I been recording? Just an R, okay. We're sick. Which expression is equivalent to negative 318 minus 2.5? That's gonna be the same, this one. Yeah. Which expression is equivalent to 10 minus 8? This one's 10 plus negative 8. Which expression is equal to negative 9 minus 4 and 1/3? So it's gonna be negative 9 plus 4 and 1/3. Yeah, it's pretty sick. Which expression is equivalent to 1/2 minus 8? So it's gonna be 1/2 plus 8. 1/2 plus 8, yeah. Done, and we're done. Whoa, didn't make a mistake this time. Subtracting negative numbers. Subtract. Okay, it's gonna be negative. Okay, it's gonna be 9. It's gonna be negative 10. This one's negative 1. And oh shit, it's gonna be 6. 14. Same shit with my. It's doubling my keystrokes if I need to fix that shit. I hate it. Let's try again. It's gonna be 7. Whoa, it's gonna be 0. It's gonna be 11. Yeah. 11. It's gonna be 1. And this is 1b7. Oh shit. Oh, okay. Another one. Okay. Oh wow, it's hard. Okay, so it's gonna be negative. I mean 9 minus 8 to 1, right? Okay. Negative 2 plus negative 3 is gonna give. So this one's gonna give us negative 5, and plus 4 is gonna be negative 1. Plus 4 minus plus 3 is gonna be positive 2. Minus negative 3. Hopefully it's correct. Okay. 10 is negative 8, 0, positive 2. So 2 minus 6, negative 4. It's gonna be 8. 8 minus 7 is gonna be negative 9. Negative 9, negative 28. Negative 28 plus 11, negative 28. Crap. It'll be negative 17, right? I'm sure. Yeah. Okay. 4 minus 2, it's gonna be plus 2. 3 is 5. Minus 6, negative 1. So 14 plus. Okay, 14 minus 9. It's gonna be 5. Yeah, it's gonna be 5. 5 minus 9. Negative 4. Holy shit, multiplying and dividing negative numbers. Okay, so probably it's the last one and then take all this. Okay. Someone's calling me again, I gotta post. Hey, I'm back, so yeah, I just grabbed some food. But now I'm having champurrado. Let's continue. I'm gonna eat while I watch.
Let's say that you are an ancient philosopher who is building up mathematics from the ground up, and you already have a reasonable understanding of what a negative number could or should the ground up. And you are, let's say that you are an ancient philosopher who is building up mathematics from the ground up, and you already have a reasonable understanding of what a negative number could or should represent, and you know how to add and subtract negative numbers, but now you are faced with a conundrum. What happens when you multiply negative numbers? Either when you multiply a positive number times a negative number, or when you multiply two negative numbers. So for example, you aren't quite sure what should happen if you were to multiply, and I'm just picking two numbers where one is positive and one is negative. What would happen if you were to multiply 5 times negative 3? You're not quite sure about this just yet. You're also not quite sure about what would happen if you multiply two negative numbers. So let's say negative 2 times negative 6. This is also unclear to you. What you do know, because you are a mathematician, is however you define this, or whatever this should be, it should hopefully be consistent with all of the other properties of mathematics that you already know, and preferably all of the other properties of multiplication. That would make you feel comfortable that you are getting this right. And later we can think about other ways to get the intuition for what these might be and why it actually makes sense. But to make this consistent with the rest of the mathematics that you know, you go into a little bit of a thought experiment. You say, well, what should 5 times 3 plus negative 3 be? Well, you already have a philosophy of adding negative numbers or adding positive to negative numbers. You know that negative 3 is the opposite of 3. If you add 3 to negative 3, you're going to get 0. So this is going to be equal to 5 times 0. 5 times 0 based on how you already thought about adding a negative to a positive. And anything times 0 is going to be 0. So this expression right over here should be 0. But on the other hand, you say, well, I want multiplying positive and negative numbers to be consistent with the distributive property. So I should be able to distribute this 5. I should be able to distribute this 5. And for math to be consistent, and math should be consistent, I should get the exact same answer. So let's distribute this 5. So if we get 5 times 3, so 5 times 3 is going, let me write it out. This is going to be 5 times 3. Let me write it with the multiplication, not the dot. I'll write the X sign for multiplying. 5 times 3, so I distribute it there, plus 5 times negative 3. And I'll do that in yellow. 5 times negative 3. 5 times negative 3. And this whole thing we just said should be equal to 0. This should be equal to 0. Well, 5 times 3, those are two positive numbers. We know what that should be. That is going to be 15. So now we get this thing, 15 plus plus whatever 5 times negative 3 is, plus whatever 5 times negative 3 is, needs to be equal to 0 in order to be consistent with all of the other mathematics that we know. Well, what plus 15 is going to be equal to 0? Well, the opposite of 15. In order for this to be true, in order for this to be consistent with all of the other mathematics we know, this right over here needs to be equal to negative 15. And so you say 5 times negative 3, in order to be consistent with all the other mathematics we know, needs to be equal to negative 15. And that's also consistent with the intuition of adding negative 3 repeatedly 5 times. Now, a slightly harder to conceive idea is multiplying two negatives. But we can do the exact same thought experiment. We want whatever this answer to be consistent with the rest of mathematics that we know. So we can say, so we could do the same thought experiment. What would negative 2 times 6 plus negative 6 be equal to? Well, 6 plus negative 6 is going to be 0. Negative 2 times 0, anything times 0, needs to be equal to 0. But then once again, we can distribute. We can distribute negative 2 times 6. So we get negative 2 times 6 plus, plus negative 2 times negative 6 plus negative 2 times negative 6. And once again, all of that's going to need to be equal to 0. Now, based on the thought experiment we just did, we said, well, this needs to be equal to negative 12. Or we could view this as going to the 6 twice in the left direction on the number line, which would get us to negative 12. Or you could say repeatedly adding negative 2 6 times. That would also get you to negative 12. And now we also saw it over here, that we multiplied a positive times a negative. We got we got the negative. So this could be, or we know that this is going to be equal to negative 12. And so we had negative 12 plus whatever this business is, is going to have to be equal to 0. Is going to have to be equal to 0 in order to be consistent with all of the other mathematics that we know. And so what plus negative 12 is going to be equal to 0? Well, positive 12 plus negative 12 is going to be equal to 0. So this needs to be equal to positive 12 in order to be consistent with all of the other mathematics we know. And so there we get the idea that this is going to be positive 12. I'll leave you there, and I'll see if I can make a few other videos that can also give you a conceptual understanding of why these are true.
Those are awesome, man.
So you, as the ancient philosopher mathematician, have concluded that in order for the multiplication of positive and negative numbers to be consistent with everything that you've been constructing so far, all of the other properties of multiplication that you know so far, that you need a negative number times a positive number, or a positive times a negative, to give you a negative number, and a negative times a negative to give you a positive number. And so you accept it, so it's all consistent, but it still does not make complete, concrete sense to you. You want to have a slightly deeper intuition than just having to accept it so that it's consistent with the distributive property and whatever else. And so you try another thought experiment. You say, well, what is just basic multiplication doing? So if I say 2 times 3, one way to conceptualize this basic multiplication here is really repeated addition. So you could view this as 2 3s. So 2 3s would literally be 3 plus 3. And notice there are 2 of them. There are 2 of these. Or you could view this as 3 2s. And so this is the same thing as 2 plus 2 plus 2. And there are 3 of them. And either way you conceptualize them, you get the same exact answer. This is going to be equal to 6. Fair enough. You knew that before you even tried to tackle negative numbers. Now let's try to make one of these negatives and see what happens. Let's do 2 times negative 3. And I'm going to make the negative in a different color. 2 times negative 3. Well, one way you could view this is...
Yeah, I'm ongoing. It's good.
Just the same analogy here. It's negative 3 twice. So it would be negative 3, and I'll try to color code it. -3, and then another negative 3. Or you could say -3 minus 3. Or, and now this is the interesting thing, instead of, over here since it said 2 times +3, you added 2 3 times. But since here it's 2 times -3, you could also imagine that you're going to subtract 2 3 times. So instead of, and up here I could have literally written +2 +2 +2, because this is a +3 right over here. All of a sudden, since we're dealing with a -3, we could imagine that this is subtracting 2 3 times. So this would be subtracting 2, subtract another 2 right over here, subtract another 2, and then you subtract another 2 right over there. And let me color code it, make sure I don't get the colors messed up. And you have another 2 right over there. And notice, you did it, once again, you did it 3 times. You did it 3 times. So this was a -3. Essentially, you are subtracting 2 3 times. And either way you conceptualize it right over here, you are going to get -6. You are going to get -6 as the answer. Now, so you're already starting to feel good about this part right over here. Negative times a positive, or a positive times a negative, give you a negative. Now let's take to the really unintuitive one. A negative times a negative, all of a sudden the negatives kind of cancel out and give you a positive. Why is that the case? Well, we can just build from this example right over here. Let's say that we had -2. Let's say that we had -2. Let me do it in a different color. Let's say that we had -2. I already used that color. -2 times -3. Times -3. So now we can do a couple, and actually I'll do this one first. We're still multiplying something by -3. So we're going to repeatedly subtract that thing 3 times, whatever that thing is. But now that thing isn't a +2. That thing that we're going to subtract 3 times is a -2. So let me make it clear. This says we're going to subtract something 3 times. We're going to subtract something 3 times. So subtracting something 3 times. That's what this part right over here tells us. And we're going to do this, we're going to do it exactly 3 times. Over here was a +2 that we subtracted 3 times. Now we're going to do a -2. Now we're going to do a -2. And we know from subtracting negative numbers, we've already built this intuition that subtracting a negative is the same thing. It's like taking away someone's debt. It's the same thing as adding a positive. And so this is going to be the same thing as 2 + 2 + 2, which will once again give you +6. You can use the same logic over here. Now, instead of adding -3 twice, and really I could have written this as -3 up in this example, -3, let me write it this way, -3, and we added it, and I'll write a plus out here to make it clear. Over here, we added it twice. We added -3 2 times. Over here, since we now have a -2, we're going to subtract -3 twice. So we're going to subtract something, and we're going to subtract something again, and that something is going to be our -3. It's going to be our -3. So negative, and put our 3 right over here. And once again, subtracting a negative, it's like taking away someone's debt, which is essentially giving them money. This is the same thing as adding 3 + 3. Negative, could have written this. Now, instead of adding negative, +6. You can use the same logic over here. Now, instead of adding -3 twice, and really I could have written this as -3 up in this example, -3, let me write it this way, -3, and we added it, and I'll write a plus out here to make it clear. Over here, we added it twice. We added -3 2 times. Over here, since we now have a -2, we're going to subtract -3 twice. So we're going to subtract something, and we're going to subtract something again, and that something is going to be our -3. It's going to be our -3. So negative, and put our 3 right over here. And once again, subtracting a negative, it's like taking away someone's debt, which is essentially giving them money. This is the same thing as adding 3 + 3, which is essentially here. And once again, subtracting a negative, it's like taking away someone's debt, which is essentially giving them money. This is the same thing as adding 3 + 3, which is once again 6. So now you as the ancient philosopher feel pretty good. Not only is this all consistent with all of the mathematics you know, the distributive property, the associative property, multiplying something times here, all of these things that you already know, it now actually makes conceptual sense to you. That this actually is very consistent with your notion, your original notion, or one of the possible notions of multiplication, which is as repeated addition.
Okay, that was pretty sick. Multiplying positive and negative.
We know that if we were to multiply 2 times 3, that would give us positive 6. And since we're going to start thinking about negative numbers in this video, one way to think about it is I had a positive number times another positive number, and that gave me a positive number. So if I have a positive times a positive, that will give me a positive number. Now let's mix it up a little bit. Introduce some negative numbers. So what happens if I had negative 2 times 3? Negative 2 times 3. Well, one way to think about it, and we'll talk more about the intuition in this video and in future videos, is, well, you could view this as negative 2 repeatedly added 3 times. So this could be negative 2 plus negative 2 plus negative 2, not negative 6, plus a negative 2, which would be equal to, well, negative 2 plus negative 2 is negative 4, plus another negative 2 is negative 6. So this would be equal to negative 6. Or another way to think about it is, if I had 2 times 3, I would get 6, but because one of these two numbers is negative, then my product is going to be negative. So if I multiply a negative times a positive, I am going to get a negative. Now what if we swap the order in which we multiply? So if we were to multiply 3 times negative 2. Well, it shouldn't matter. The order in which we multiply things don't change, or it shouldn't change the product. Whether we multiply 2 times 3, we'll get 6, or if we get multiplied 3 times 2, we'll get 6. And so we should have the same property here. 3 times negative 2 should give us the same result. It's going to be equal to negative 6. And once again, we say 3 times 2 would be 6. One of these two numbers is negative, and so our product is going to be negative. So we could write a positive times a negative is also going to be a negative. And both of these are just the same thing with the order in which we're multiplying switched around, but this is one of the two numbers are negative, exactly one. So one negative, one positive. One positive number is being multiplied. Then you will get a negative product. Now let's think about the third circumstance, when both of the numbers are negative. So if I were to multiply, I'll just switch colors for fun here. If I were to multiply negative 2 times negative 3, and this might be the least intuitive for you of all, and here I'm just going to introduce you to the rule, and in future videos we'll explore why this is and why this makes mathematics more all fit together. But this is going to be, you say, well, 2 times 3 would be 6, and I have a negative times a negative, and one way you can think about it is that the negatives cancel out. And so you will actually end up with a positive 6. I actually don't have to write a positive here, but I'll write it here just to re-emphasize. This right over here is a positive 6. So we have another rule of thumb here. If I have a negative times a negative, that they're actually going to, the negatives are going to cancel out, and that's going to give me a positive number. Now with these out of the way, let's just do a bunch of examples, and I encourage you to try them out before I do them. Pause the video, try them out, and see if you get the same answer. So let's try negative 1 times negative 1. Well, 1 times 1 would be 1, and we have a negative times a negative. They cancel out. Negative times a negative give me a positive, so this is going to be positive 1. I could just write 1, or I could literally write a plus sign there to emphasize that this is a positive 1. What happens if I did negative 1 times 0? Now this might say, wait, this doesn't really fit into any of these circumstances. 0 is neither positive nor negative. And here you just have to remember anything times 0 is going to be 0. So negative 1 times 0 is going to be 0. Or I could have said 0 times negative 783. That is also going to be 0. Now what about let me do some interesting ones. What about, I'll pick a new color, 12 times negative 4? Well, once again, 12 times positive 4 would be
negative
48. And we're in the circumstance where one of these two numbers right over here is negative. This one right over here. If exactly one of the two numbers is negative, then the product is going to be negative. We are in this circumstance. We are in this circumstance right over here. We have one negative, so the product is negative. You can imagine this as repeatedly adding negative 4 12 times. And so you would get to negative 48. Let's do another one. What is 7 times 3? Well, this is a bit of a trick. There are no negative numbers here. This is just going to be 7 times 3. Positive 7 times positive 3. The first circumstance, which you already knew how to do before this video. This would just be equal to 21. Let's do one more. So if I were to say negative 5 times negative 10. Well, once again, negative times a negative. The negatives cancel out. That you're just left with a positive product. So it's going to be 5 times 10. It's going to be 50. The negative and the negative cancel out. Your product is going to be positive. That's this situation right over there. Now that we know a little bit about multiplying positive and negative numbers, let's think about how we can divide them. And what you'll see is that it's actually a very similar methodology. That if both are positive, you will get a positive answer. If one is negative, but not both, you're going to get a negative. Now that we know a little bit about multiplying.
Oops, topic? Dividing positive and negative numbers.
Multiplying positive and negative numbers, let's think about how we can divide them. And what you'll see is that it's actually a very negative numbers. Let's think about how we can divide them. And what you'll see is that it's actually a very similar methodology. That if both are positive, you will get a positive answer. If one is negative, but not both, you're going to get a negative answer. And if both are negative, they will cancel out and you will get a positive answer. But let's apply it. And I encourage you, pause this video and try these out yourself and then see if you get the same answer that I'm going to get. So 8 divided by negative 2.
Yeah, it's good.
So if I just had 8 divided by 2, that would be a positive 4. But since exactly one of these two numbers are negative, this one right over here, the answer is going to be negative. So 8 divided by negative 2 is negative 4. Now negative 16 divided by positive 4. We have to be very careful here. If I just had positive 16 divided by positive 4, that would just be 4. But because one of these two numbers is negative, and exactly one of these two numbers is negative, then I'm going to get a negative answer. Now I have negative 30 divided by negative 5. If I just had 30 divided by 5, that would be positive 6. And because I have a negative divided by a negative, the negatives cancel out, and so my answer will still be positive 6. And I could even write a positive out here. I don't have to, but this is a positive 6. A negative divided by a negative, just like a negative times a negative, you're going to get a positive answer. 18 divided by 2, and this is a little bit of a trick question. This is what you knew how to do before we even talked about negative numbers. This is a positive divided by a positive, which is going to be a positive. So that is going to be equal to positive 9. Now we start doing some interesting things. Here's this kind of a compound problem. You have some multiplication and some division going on. And so first, right over here, the way this is written, we're going to want to multiply the numerator out. And if you're not familiar with this little dot symbol, it's just another way of writing multiplication. I could have written this little X thing over here. And what you're going to see is in algebra, the dot becomes much more common because the X gets used for other there's a not the times symbol people don't want to confuse it with the letter X, which gets used a lot in algebra. And so that's why they use the dot very often. So this just says negative 7 times 3 in the numerator, and then we're going to take that product and divide it by negative 1. So in the numerator, negative 7 times 3, positive 7 times 3 would be 21, but since exactly one of these two are negative, this is going to be negative 21, and it's going to be negative 21 over negative 1. And so negative 21 divided by negative 1, negative divided by a negative is going to be a positive. So this is just going to be positive 21. Let me write all these things down. So if I were to if I have a positive divided by a negative, that's going to give me a negative. If I have a negative divided by a positive, that's also going to give me a negative. If I have a negative divided by a negative, that's going to give me a positive. And if I have obviously a positive divided by a positive, that's also going to give me a positive. Now let's do this last one over here. This actually is all multiplication, but it's interesting because we're multiplying three things, which we haven't done yet. And we could just go from left to right over here, and we could first think about negative 2 times negative 7. Negative 2 times negative 7, they are both negative. The negatives cancel out, so this will give us, this part right over here, will give us positive 14. And so we're going to multiply the positive 14 times this negative 1. Times negative 1. Now we have a positive times a negative. Exactly one of them is negative, so this is going to give me a negative answer. It's going to give me negative 14. Now let me give you a couple of more, I guess we could call these trick problems. What would happen if I had 0 divided by negative 5? Well, this is 0 negative fifths, or 0 divided by anything that's non-zero is just going to be equal to 0. What if we were to do the other way around? What happens if we said negative 5 divided by 0?
Oh no.
Well, we don't know what happens when you divide things by 0. We haven't defined that. There's arguments for multiple ways to conceptualize this, so we traditionally just say that this is undefined. We haven't defined what happens when something is divided by 0. And similarly, even if we had 0 divided by 0, this is still undefined.
Oh shit, times 8. So if I do 8 first, it's going to be 80, 16, 96, negative 96. Next article. Dividing negative numbers. So positive, 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 negative. Yeah, same methodology. Shoot. Not gonna take a quiz first, we're gonna do the practice, then the quiz. What's the sign of 9 times? Let's say negative. What is the sign of negative 4ab when a is greater than 0 and b is less than 0? Wow, this is pretty hard. What the hell? What is the sign of negative 4ab? Shouldn't be. A is greater than 0. Let's say this is 2. And then b is less than 2. To negative. It's gonna be positive, right? So this thing's gonna be negative. If you multiply this, it's negative, positive. And then we give negative times negative, it's gonna be positive. Let's cancel each other out. What is the sign of a times negative b? Oh wow, it's pretty crazy. Negative b. Oh shit, it's gonna be positive, right? No, I think positive, man. No way. Negative b? Negative 2 to negative 2. It's gonna be positive. What the hell? Oh shit, it's 0. What the fuck? I got debated. What's the sign of 4, negative 4? Step. Sign of c divided when c is greater than negative. Sign of ab. This one's gonna be positive. 0, man. Let's try again. Got debated. P is greater than 0 and Q is equal to 0. Yeah, it's going to be 0. What is the sign of y divided by x? 0 the heck? I don't want to get debated again. What is sine of 4.3 times negative times 0? What the heck with the zeros, man? What is sine of when a is equals to 0? What the heck? Okay, no 0 this time. So it's a negative and so it's negative because x is negative and y is a positive, so it's negative. Wait, no. Because this is x, negative and positive, this is negative, and y is positive. Oh shit. Okay. Let's think of it. X is negative and y is positive. So this thing's still gonna be negative. The negative times positive. It's not negative, yeah. What is the sign of negative 4 times... Oh shit. Okay, it's gonna be positive, right? Yeah, man. Sure. What is the sign of when x is greater than 0 and y is greater than 0? How about positive? Yeah, because both are greater than 0, and then both's gonna be negative. Then yeah, same sign. Multiply negative numbers. Let's go. Shite. Give me 7 plus 4. What is the sign of BC? B is positive and negative. Yeah. Which expression is equivalent to negative 8.2 minus 5? Negative 8.2 plus 5, yeah. Sick, we're done. Quiz. Wow, I'm pretty fast. I'm 2 hours in and I knew the unit test. Let's do the unit test. Okay, 12 questions. Let's not make any mistake. Negative 5 minus negative, it's gonna be 20. Okay, it's gonna be 20, negative 20. Plus 4 is negative 16. Plus, and we negative 1. Order the following from least to greatest. So the least is that. Oh shit. Oh my god, I can press. So, no. Yeah, 6 more. Alright, cool. Let's go. Fill in the blanks, they're equal. E. Move the dot to negative. It's gonna be end up at 3.5. We're gonna negative 0.5 cancel out. It's gonna return positive anyway. Hey, wow, it's gonna be 8. Yeah. Move the dot to -7 on the number line. So it is -7 on the number line. A turtle challenges the Greek warrior, Achilles, to a race outside the gates of Troy. Achilles accepts. The turtle and Achilles start from the gates of Troy and race in a straight line away from the city. They keep a constant speed throughout the race. Wow, okay. Yeah, it's constant speed. I mean, it could still be different speed, but constant. During the race, Achilles is F meters from the gates, while the turtle is only G meters from the gates. The following expression always represents this between the turtles and Achilles during the race. Oh, yeah, it's this one. Last month, Claire's bank statement said that she overdrew her account. Her bank balance was negative 445.33 euros. This month's Claire's bank balance 70 euros. What does this mean? What does this all mean? Claire's bank balance 17.9 euros. Overdrew? What does that mean? Man, I don't want to mess it up. What is this overdrew? But I'm pretty sure A is correct. How an ordinal account is presented with negative balance. Oh shit, okay. What is the sign -5? It's gonna be positive and then negative. So it's gonna be negative, right? Yeah. Oh, it's gonna be -5. Which expression is equivalent to 7 3/4 minus 1/2? 7 3/4 plus -1/2. One answer. Okay. 4 to 5, man. Oh shit, that's the last question. Oh, yeah, chip mastery. Okay, it's cool. Okay. So I finished this section. Everything. I perfected the practices and then perfected the quizzes and then the unit test. Wow, pretty sick. Okay, but this one's pretty short. But yeah, kind of made it 2 hours in the videos. So it's kind of the bare minimum. The next section is gonna be huge. Yeah, it's exciting. So let's check. We have 43% now. From 35 to 43%. Wow, it's pretty sick. Got new notifications. Great listener, negative, multiply. Yeah. Let's see. Oh, great. It's large. Points. So cool. Let's go to our missions. What's our percentage in the world of math? 11%. Oh, I gained 1%. That's pretty sick still. Pretty good. Yeah, 11%. That's pretty good. Okay, tomorrow again. Gonna continue with that. I guess it was fraction, right? That's was fraction. Okay, thanks. Tomorrow again. Bye.